Hi, Matthew.
Hey, Jack. What are we going to work on today?
I wanted to work on some math today. I have a quiz review that I want to work on.
Okay. Have you sent it over to me?
I sure will. Let me make a
Okay.
copy of it.
All right.
Oh, excuse me. Oh, I share the doc with you. I don't want to like do it on a doc. I'm gonna do it by paper, but I just wanted to share it with you so that you could see it.
Okay. I'll open it up and I'll start snipping the questions in.
Perfect. Sounds great.
All right. So let's see here. We got decide whether each function is one-to-one. All right. If so, find its inverse. Okay. It's always easy to tell when something is not one-to-one. It's usually a little easier because it just has to fail a test or not do something that you expect it to do.
Yeah.
Any idea what this graph looks like roughly? Like, does it open up or down? Does it? Can you give me any information on this one on the left here?
I know that it reflects off the y-axis across the x-axis and it goes down one.
Yeah. So like the original graph looks like that. This negative flips it. This 2 stretches it, and then the -1 goes down one. So the net effect from all that is a graph that goes like that.
Yeah.
Do you remember from the other night the horizontal line test?
Yes, I do.
If it hits
This
it
definitely
twice,
fails it.
it's not it's not one-to-one.
Yeah.
So this is a no-go here. We should do 3 next.
All right.
Because it's sort of in the same realm, I guess. I'm kind of curious how they want you to do it in class, because if you don't know how to graph these, you're sort of at a huge loss. So x cubed looks like this.
Mm-hmm.
The negative flips it, so it looks like this. The 4 kind of stretches it, and then the 5, it actually goes up 5 because it's +5.
Oh, okay. So this definitely makes the test. So yes, right?
This one is good because a horizontal line only hits it one time.
One time.
Yeah. So I mean, there's a few other ways to do it, but this is probably the cleanest. So now we have to now actually find its inverse. Okay, so I'm going to rewrite it down here. I'm going to write y instead of f of x, 4x cubed. Okay.
Mm-hmm.
So the first thing you do is you switch x and y.
Oh, all right.
So you switch x and y, and then you want to solve for y, and that could involve any number of steps. But for example, here we're actually move the 4y cubed over. So you subtract x, you add that. Okay, and then you divide by 4. So you have y cubed equals 5 minus x divided by 4. Take the cube root of both sides. So you get something like this. So this is the inverse here. When we're all done, you just change the y to f
F negative
inverse.
1x.
Yeah.
All right, then we get cubed, and then I put that 5 minus x over 4. Awesome. All right. Can we go back to 2 and see like how do we do that one?
Yeah, so 2 is different, and the reason is it's different is they're giving you a set of ordered pairs. So what you're looking for, and it's see, when you're trying to decide if something is a function, you look at the x values, look at duplicates in the x. To decide if it's one-to-one, you look for duplicates in the y.
And there is one duplicate 8.
Yeah. Now then you're looking for, are these the same, the ones that have arrows underneath them?
Are they the same?
Are they the
No.
same? Okay, so if we were to graph these, and we can make a really rough sketch of those 2 points, 2, 8, which is, we'll just say our origins here. So 2,
Oh,
1, 2,
is
3,
it?
4, 5, 6,
Does it
7,
end up
8.
failing the horizontal line test?
It
So it's
does. It does. See how
all right.
horizontal line would go through both of those? So this one is not invertible. All right. Is it okay if we move on to 4 now? Is everything kind of clear thus far?
Yeah, it's all clear.
All right.
Sounds great.
State whether the function is increasing or decreasing without a calculator. Show all work and a table. Give the domain and state if the function is increasing or decreasing. Okay, so a couple of duplications of that. So we've got an exponential function here. To tell if something is increasing or decreasing, it depends on two criteria. The first thing it depends on is the number inside the parentheses. Okay, and the second thing, it depends on whether the exponent is positive or negative. So there ends up being like 4 cases that you have to learn. Here, because this number is less than 1 and it's a positive exponent,
All right.
this one is decreasing. But for example, if it was a negative exponent, the fact that it's less than 1 would be offset by the fact that there's a negative exponent there.
All right.
Now, it does say to make a table. The fact that you've got to make a table is a little bit challenging here because it's a fraction inside there. So we're going to start at 0 because anything to the 0 power is, do you recall?
I think the 0 power is 1.
1. Okay. Anything to the 1 power is itself.
Mm-hmm.
Now, do you recall from class, did your instructor maybe say, we want, 3 points, 5 points? Do you remember what they said?
Just like 1 or 2 to the left or the right.
Okay. I mean, 3 is a minimum in sort of my world. So if f of x equals 2/3 to the power of -1, the -1 here just flips it. It becomes the reciprocal, 3
Negative.
halves.
All right.
Not negative. It just flips
Oh, never
flips
mind.
the, flips the fraction.
I forgot about that.
Okay.
There we go.
This is where it gets like, okay, if you're going to do another one, if you do -2, you have to flip it and then square. If you put a 2, you're just squaring. Either are fine, but just to maybe help out here, we'll do 2/3 to the -2 power. The first thing you're going to do is flip that. I'm sorry. So it's going to be 3 halves squared, and then you square the top, square the bottom. So another way to figure out whether it's increasing or decreasing is to look at this list here and see that these numbers are getting smaller, which means that it's decreasing.
Oh, I see what you mean. Okay.
So they give you a graph here. What your instructor is looking for is whatever you end up graphing, it better go like that. Okay, like you shouldn't, like if you have a graph that goes anything other than this sort of shape, they're going to know that you've done it wrong. So this is the kind of thing that you just want to be very careful with how you fill it out, and because the numbers are so tight together, you just have to pay a little bit more attention to it here. So the last thing is the domain. The domain is all real numbers for these always.
All right.
I'm going to just snip in a graph from Desmos, and we can move on to the next question here. I think that'll be sufficient for what you're looking for here. So we'll paste that in. Of course, it's a gigantic graph here. Okay.
Oh, I remember these.
Yeah. Not sure why they're included in this part of the class, but they are. So we're gonna do them. All right, we're gonna go to number 5.
Yes.
So there's a couple of things that you can do to number 5 to sort of answer, these questions about whether it's increasing or decreasing. This one's different because there's this +3 here. Now there's a property that says if you have like x to the n plus m, this is the same as x to the n times x to the m. And what that means is each of these exponents goes with the base. So this is really 2 to the x times 2 cubed. And you might be wondering why I'm doing that, and it's to help with trying to figure out whether it's increasing or decreasing. So this is 8. We can write that in front. 8 times 2 to the x power. So this number 2, this is greater than 1. Since it's greater than 1, it's increasing because it's also a positive exponent. So this is increasing. So if it were greater than 1, but it had a negative exponent, instead of increasing, it would be decreasing.
Oh, all right.
Now, what some students can do is they can recognize this and say, oh, what this really is 2 to the x is the parent function, and the x plus 3 means it's going left 3 units.
Oh,
And that's true. That's totally true. This is also true. So it's depends on depends on what you want to how you want to look at it, but it's lots of things are true here. So we can make a table. I'm actually going to go back and use the original function here, the 2 to the x plus 3, because I want to illustrate some points here. We're going to actually center the graph at -3. And the reason
mhm.
is because -3 plus 3 in the exponent becomes,
All right, so we put -3 in there. It should be 1, right?
it becomes 0 in the exponent, which the whole thing goes to 1.
Yeah.
Okay. Now, the next number we want in the exponent is 1. So if I put -2 in, 2 to the -2 plus 3 is really 2 to the 1, and that's 2. It's just
Mhm.
itself. If I put, I'm sorry, I put these in the wrong positions. So I sometimes do that. That's all right. So if we go -4, 2 to the -4 plus 3 is 2 to the -1. Negative means you flip it. What is the flip of 2?
A flip of 2. Just 1/2, right?
1/2. Yep, you got it. And then we get in that scenario again where it's like, well, which way do we go? We haven't done anything sort of nice. So let's do -1 here. 2 to the -1 plus 3 is 2 squared, which is 4. Do you see how if you go down this way, the numbers are getting larger?
Yes.
That means it's increasing.
Yeah.
But
All
you
right.
have to make sure the numbers on the left here are also getting larger. You have to do it in that way.
Oh,
So the
that's what.
graph of this, it's going to look something like this. I will snip in a complete graph from Desmos here, but there's kind of a lot that goes into that problem that you may or may not get on the first time. So, I don't know if you've been doing it, but definitely check out the video recording because I have to watch things several times sometimes to just figure out what's going on. All right, so domain. Last thing here, all real numbers minus infinity to infinity.
Mhm.
Okay, number six. Number six here. Solve each equation without a calculator. All right. So we're moving on to something totally new, but it's related to the previous stuff, I suppose. Um, we actually should start with 8 or 7. Let's start with 8. I'm actually surprised at the order of these. So there's a when you're solving, this is part of a category we would call like solving equations, um, trying to get the same base.
Mhm.
So like when I look at 64, I realize 64 is 4 to the power of 3, which happens to be the same base as 4.
Oh, all right.
And the property we're using here is if you have the same base, you can set the exponents equal. Okay, we need to do a little bit
Oh,
more
okay.
here. We have to apply a property that says if you have an exponent to an exponent, you multiply them. So this is 4 to the 3x. equals 4 to the 1. Because the bases are the same, you can set the exponents equal. So you end up just writing 3x equals 1, divide both sides by 3, and that's your answer.
Oh. Oh, okay. I think I remember how to do this.
You've probably seen this before. We're going to look at 7
I know that
next.
for sure. I know for sure 6 is 5 because there's only one way for it to get to be 1, like that.
Yeah, and that's kind of a property. That's why I was surprised it was there. But we're going to do 7 next because it's the same principle. You either want to make 8 into a 2 or 2 into an 8. Well, it's easier to go down because 8 is really 2 to the power of 3.
Oh, okay.
Since the bases are the same, you're in good shape here. But you can't quite do that yet. You have to take this 3 and apply it to both of these in here. So the left side stays the same, but the right side becomes 2 to the 3x plus 9. Because the bases are the same, you can set the exponents equal. If you subtract 2x from both sides,
Should be -8.
x equals -8. So I want to give you one real quick to solve here because they didn't really cover the. So let me go. 64 to the 2x minus 1 equals 16 to the 3x minus 2.
All right, I can do that.
This is sort of the next step up. Um, so give yourself
Yeah.
60 seconds and see if you can figure that one out, please.
I got 1/2. Are you muted, Matthew? Because I can't hear you if you're talking.
Yeah, sorry about that. What I was saying is you can't go from 64 to 16, and you can't go from 16 to 64. So what did you turn 64 into? What did that become?
64 and 2. Oh my, I did that very, very wrong. 4. Yeah, it's 4. It's 4. All right, that should have been 4 to the 4. It shouldn't have.
Well, it's actually 4 cubed, and that's fine because 16 turns into 4 to what power?
4. Wait, 4 to 16. 4 to the what turns into what power? Say that one more time.
You're trying to figure out what number to what power equals 16. It's two variables, a base and an exponent.
Oh, 4 squared.
Or squared. And the reason it's 4 again is because you chose 4 over here.
Yeah.
So these are 2x minus 1, 3x minus 2.
Yeah.
So actually inadvertently, I need to change one of these. So we're going to make this 3x and then 3x. So now you're going to multiply the exponent. So it's 4 to the 9x minus 3. This is 4 to the 6x minus 4. Because the bases are the same, you can set the exponents equal. You can set 9x minus 3 equal to 6x minus 4. And then you can solve from there. Sounds like you did something different. If you want another one, let me
It's
know.
fine.
But
It's fine. I think that these. I think I'm doing pretty well. I can do pretty well with these.
okay. So let's just briefly look at 6. I mean, you already answered it. The fact that it's 1 over here, what that really means, and you're very clever. I mean, you figured this out right away. This is 12 to the 0 power on the right. That's what 1 is. So you
Yeah.
set x minus 5 equal to 0, and you realize x has to be 5. It probably helps that we said over and over again, anything to the 0 power, n to the 0 power always equals 1.
Perfect.
Okay, let's move on to number 9. Number 9
Yes.
appears to be a calculator question. It does say to show your equation. Okay, you decide to invest $1,700 into an account that pays 1.5% annual interest. There are two accounts you can choose from. One pays interest quarterly and the other pays interest continuously. Show how much money you would have in each account for 6 years. Which account should you use? So there's really two problems. It's the first problem, part A, which they don't say, is to figure out if you do quarterly, how much do you have?
Four.
And
Yeah, you
and
get to the fourth power, right?
so there's a formula here. The amount that you have is the principal 1 plus your interest rate divided by the number of compounding periods, which is n, to the n times t. So this is the formula that you're using. Your principal, the amount you're starting with, is 1,700. Your
Yeah.
interest rate is 1.5%. You never work with the percents in math equations. You have to convert that to a decimal point 0.015. And this is super critical because it's quarterly, n equals 4. T is 6 years. So notice that I've given you P, R, N, and T. You have enough to be able to find this value. What usually happens is there's calculator errors. So really take plenty of time to enter this correctly into the calculator. When it says to show your equations, they want you to show exactly what I've got here. Give that a try, and then I'm going to write down the answer that I get, and we'll compare.
I end up getting 1859.78. 78, yeah.
That's what I got as well. So it looks like we're in good shape here. All right. Okay, so then now we have to do it for continuous. Continuous is a completely different equation. The amount
That
that you have,
acre or whatever.
yeah, it's P e to the RT. Your P is the same, it's 1700. Your R is still 0.015, and your T is 6. Notice there's no N in this one. So it's just a calculator exercise. Can you get this into the calculator correctly? If you don't know this, you will be getting a bigger number with continuously compounded interest. It's no one does this, but it is way better because it's continuously compounded. It might not seem like much for this particular problem, but it can actually be a big deal when you're dealing with much larger sums of money and longer periods of time.
I'll keep that in mind. I end up getting 1860.096. So I can round that up to 1816. 18. Oh my god. $1,860.10.
Yes, and to just close it out, it says how much money would you have in each account? We've answered that. And then which account should you choose? And it would be the one on the right because you'll have more at the end.
So you should invest in continuously compounded plans or whatever.
Continuously compounded interest, but that's always the case, especially if everything else is the same. The um,
continuously compounded accounts or interest?
Interest account. Yeah, I mean, you can just say account too. I mean, it's kind of obvious. I mean, I think the instructor just wants a sentence here that says, choose the second option because it's more.
You end up getting more out of your account.
Yes.
All right, on to number 10.
Okay, so number 10 moves to a new type of question. It says write the following equation in logarithmic form. It helps if I just write the answer and then we see where each of the pieces move and then you follow that. So log base 3 of 81 equals 4.
Yeah.
So 4 comes over here, the 3 comes over here, and the 81 goes right there. So why don't you try number 11 on your own, and I will help you read it out loud. It's sometimes you can say it improperly but have the right answer. Actually, I'll write what this one is. This is log base 3 of 81 equals 4.
I got log base 125 equals 3.
Okay, so you have you maybe you wrote the right thing, but you didn't say the right thing. So this is log base 5 of 125 equals 3. Or maybe I heard something different. Maybe I heard log base.
I said log base 5 125 equals 3.
Yeah. Okay. So maybe we are in the same. These go here and these go here.
You just switch them around.
Yeah. Now 12 is exactly the same. It just looks different. But it's the same steps. It's the same, like putting the things that we just put in, whatever order we put them in. We're going to do this again.
Log base 1/3 to the 9th equals -2.
So it's log base 1/3 of 9 equals
of 9.
-2.
All right.
It's not. I think you said to the 9. I mean, it's not an oral exam or anything, but it's important to know how to say it correctly.
Yeah, properly. Yeah. All right, on to number 13. Now
So
we
13's going backwards. Math is forwards and backwards. This one is no different.
Should be easy. 5 to the negative second, 5 to negative 2 equals
yeah, and this is all you have to do. You're done. Like that's it. There's no extra step here. I think sometimes there's this desire to like do more. Or you're like, am I done? Yes, you're done. 14 has a slight wrinkle in it that we haven't talked about. If the base is not shown, it is assumed to be 10. So there's really a 10 here that is not shown.
So 10 to the second equals 100?
Yes.
Perfect.
All right, so 15 and 16 are related, I guess. Well, they're slightly different, I guess. So now we're solving logarithmic equations with logs in them. This one on the left, the variable's on the right. So the variable's on the right. So all you got to do is simplify the left-hand side. To simplify, you need to know property of logarithms, like log base n to 1 of 1 is 0. Log base n of 1 is 0. That's an interesting property. Log base n of n, like if the base is the same as the number, that equals 1. Log base n of n to a number, I don't know, put a c up there, becomes c. Okay, so what I'm trying to show you here is a progression. This progression should indicate that we really want this 32 to become 2 to some power. So 2 to what power is 32 is my question to you.
2 to the, what's it, 2, 4, 4, 8, 16, to the 5th.
To the 5th. So this whole thing becomes log base 2 of 2 to the 5th equals x. Now, according to this property over here, this becomes just 5. But let's go through this a little bit more. You actually can bring this number out in front. So it becomes 5 times log base 2 of 2. This right here is equal to 1. So we have 5 times 1, and I didn't even bring the x down, equals x. So it ends up being that x equals 5.
So x equals 5. All
Yes.
right.
If you understood that, let's try another one here. So let's say log base 3 of 81 equals x.
Sorry, I had to go do something. I'm back.
Okay.
All right.
So the question is what is log base 3 of 81? It's just like the last problem. You have to write 81 as 3 to some power and simplify it. We definitely covered this in the summer.
Yeah, I think I remember this. It's like 3 by 3. That should be the fourth, right?
Yep,
Like,
x equals 4 when you're all done. Great. Okay, let's move to 16. So 16, I'm going to snip it in here. It's very different than the previous one because the variable is now in a really unusual place. Its position is the base. Okay. So the first thing you got to do here, which isn't obvious, is you need to convert this. Whoa, that was not what I wanted to see. Is you need to convert this to exponential form. So basically, what we did in question 13 and 14, I need you to do that here. So if you need to look up in your notes, do that. I can scroll up if you'd like, but I want to hear what you get when you convert this to exponential form.
oh, exponential form? Oh. X squared equals 15.
Okay, now this is not there's nothing
Yeah,
complicated.
there's nothing about work.
How do you undo a power of 2?
Square root both sides.
Or both sides. So
X
x
equals square
equals
root 15.
square root of 15.
And
You
if you
got it.
want to, you can show the decimal form, but I'm pretty sure she's not going to want it.
That's right. That's right.
All right.
Okay, now 18 and 17 are expand or condense problems. We're going to do the expand problem first, which is 18. You end up using these in calculus. You're kind of on a track for that, in college. I would assume. So, there is a reason to do this here. Lots of properties though. So the properties you have to work with here is that if you have a log base b of m over n, this equals log base b of m minus log base b of n. So in your problem, all of this stuff up top here is m. All of this stuff down here in the bottom is n. Do you follow that?
Yeah, I think I see what you mean.
So your first step here is to use this property top left and rewrite it as log base 3 x squared y to the fifth minus log base 3 of z squared.
X squared y to the fifth minus log. Oh, yeah, because of the subtraction, because of the division turns into subtraction, basically.
Right. So now I'm gonna write another property. If you have log base b of m times n, this equals log base b of m plus log base b of n. Basically, a product becomes a sum. So this is your m, and this is your n, meaning x squared is your m, your n is y to the fifth. So we're going to break this one apart using this property down here. So it's log base 3 x squared plus log base 3 y to the fifth. And then you just keep this next part, you just bring it down, minus log base 3 z squared.
Oh, okay.
Now there's yet one more property we're going to use. If you have log base b x to the n, this becomes n times log base b of x. Essentially, the exponent moves out.
In front?
Yes.
Oh, I remember this. Okay.
So in this case, the 2 comes out in front, the 5 comes out in front, and the 2 comes out in front. So you get 2 log base 3x plus 5 log base 3y minus 2 log base 3z. And we're done.
Perfect.
So to do 17, I know I'm like kind of ready. I'm like, all right, let's do number 17. You basically undo the 3 steps we just do here, meaning you first deal with the numbers out in front, they become exponents. Then you combine sums into products, and then you apply quotients. I'll of course walk you through it, but it's just doing exactly what we did in reverse, forward and then reverse. So the first property we're going to use here is that log base b, n times log base b of x equals log base b of x to the n. We're just moving this exponent. So in
Oh
this case,
no.
this is your n and this is your n. So it becomes log base y of a squared, all of that to the power of 4, minus log base y of b to the power of 3.
Can we do anything else with it?
Yes, there's lots more to it, but is that okay?
Yeah, I understand.
So this one has an added little wrinkle that it has log base b of m to the n power, which sorry, to the I guess I gotta use another, to the r, I'll say. So this becomes log base b of m to the n times r. So you end up multiplying this. So here you got to multiply the 2 times 4. So it's log base y a to the power of 8 minus log base y b cubed. If that's okay, if that's clear, we'll move on to the next property, which is log base b of m minus log base b of n equals log base b of m over n.
Okay, I think that makes sense to me. So
So
it
this is,
end up turning to log base y. What would it be? A square. No. Sorry about that. Oh, all right.
there's
Log
only
base y.
one log when you're done condensing it.
Perfect.
So what would be a good exercise, and we don't need to do it right now, but if you wanted to do it like as part of just practicing after the video, would be to take this one right here and expanding this and making sure you get back to the original, or condensing this. If you were to condense this, that would be a good practice thing to do, because you should get back to what you started with in the original problem.
All right, sounds fair. I shared with you another worksheet that I wanted to try.
Okay, let's take a look here.
Should say 5.3 properties of logarithms practice worksheet.
Yep, I see that here. Okay, so the ones, these would have been good to do before these, but they should go pretty quickly because you've just done sort of harder problems, quiz type questions here.
Mm-hmm.
Okay, so the only thing about the snipping here is not big enough. So this one, you're going to bring the the number in front to become an exponent. So this becomes log base x of 6 minus log base y of 36.
Log base y 36. All right.
Now you can combine this because it's subtraction. This becomes log of x to the 6th over y to the 36th.
And that should be it for that one, right?
When you get down to a single log, you know you're done.
Perfect.
You know you're done. So let's go to number 2.
All right, we turn into log base 4x to the 4th, then plus log, plus log base base 4 of y to the 2nd. Now what do we do with this?
Well, it's a plus. So this time a sum becomes a product.
So multiplying?
Yes, you can only have one log. So these things in here that I circled, they come down in here. So it becomes x to the fourth times y squared.
And do we just leave it like that?
Once you're down to a single log, you're basically done.
Perfect. All right.
So number
3.
three is a lot like number two. It's just got three terms instead of two. So give that one a shot here. You're gonna bring the number in front as the exponent first, and then you're going to combine them all into a single log.
This one just turns to log base 7 to the x squared times y cubed times z.
Yep. Great. Four's got a little wrinkle to it. We'll work it out together. It's probably the one you'd see on a test or quiz because it's got the opportunity for
Confusion.
confusion and somehow instructors like that. So we're going to do the same thing we did before. We're going to bring that number in front as the exponent.
All right, so got all worked out now. What do we do?
Okay, so if you just focused on the first two, okay, it would be log base 9 x to the sixth over z. Do you agree with that?
Yeah, I do agree with that.
Okay. Now this over here, it just means you're dividing. So like if you're using this property log base b of, I'll use a this time, minus log base b of b, and this becomes log base b of a over b, you're going to just write this in the numerator, the x to the sixth over z.
Mm-hmm.
And then in your denominator is this other one, this y to the sixth. Now we're going to simplify this, but it's the same thing. You're just putting something over something, and then we'll talk about the general rule here. So this becomes log base 9, and you can just sneak this y to the sixth up into the denominator at the top. So it becomes x to the sixth over z y to the sixth, like that.
Oh.
So basically anything that's subtracted is going to go in the bottom.
Uh-huh.
So the kind of a general rule here is subtracted terms, they go into the bottom. Added terms, they go into the top.
That makes sense.
All right, let's
go
do
to 5.
We're gonna do 7 first because it's the clearest of them all. For I don't know, it's weird. Your instructor's putting these in an order that's not good for learning. Okay, so this is a lot like the ones we did on the assignment here. It's a product of these two things. So you're going to break it apart. Product goes to a sum. Product goes to a sum. So log base 3 x squared plus log base 3 y to the sixth. The next thing is that you can bring each of these exponents out in front. So that's 2 times log base 3 of x plus 6 times log base 3 of y.
Mm-hmm. Should I do any more?
Yeah, so you're done here. It may not be clear that you're done because you have like more stuff. Like it got worse. It's like getting out of bed in the morning. The bed looks worse than when you make it. Yeah, you're done. You're done. Once you've applied the rules, the sum to product. I'm sorry. Once you've applied this product to sum and then dealt with the exponents, you're usually done.
Perfect.
Okay, so
Which problem you want to go to?
we're going to go to 5 next. I'm just going to rewrite it because that 5 out front looks weird. Next one, 6th, 5th. Okay, there's 2 paths on this problem. Path number 1 is to bring this exponent out in front. Okay, path number 2 is to apply this exponent to both things in here. Which one do you think you'll go down if you were to given this on a test or a quiz?
I probably would take 5 in the front of the log.
Okay, so let's do that first. So it's 5 times log of xy to the 6th. Now I'm going to write this slightly differently. I'm going to put 5 parentheses log xy to the 6th because I really need to emphasize something that's about to happen. Do you agree that this is a product inside here?
Yes, I do.
So the product gets split apart. Log x plus log y to the 6th. Does the 5 go with both of these, one of these, none of these? What do you think? Both. Okay. And that's an easy thing to not see. The last step here is to deal with the exponent here, this 6. You bring it out in front, you multiply 5 log x plus 6 times 5 log y. So it's 5 log x plus 30 log y.
Perfect. On to number 6. Why would they put 77 times 80 times 11 in there?
Yeah, not sure, but we're going to look at it and see. We're going to break it apart the way we did before. This is a product. So this becomes log base 876 plus log base 8 of 11. Can you at least get that far?
Yeah.
Okay, so the next thing is to look at 76 and decide like what makes up 76. Well, it's 2 and 38, 2 and 19. And then we stop there at 19 because it's a prime number. So what we're hoping for, and this isn't a good example of this, I do a question of the day that has really good emphasis on this. If you could break 76 into something with an 8, like let's say this was 80 and it was 8 times 10, you could then reduce it. But this is done. You're done at this step because there's nothing further to do. Like if you had three twos over here, then you could do something, but you don't. So if that's not clear, I don't think it really was. We're going to do log base 2 of 6. Actually, that's probably not a good number. Let's do it of, I'll just write it this way, 2 times 3. I'll try and do this real quick. So log base 2 of 2 plus log base 2 of 3. Since these match, do you remember what this becomes, what the property says when these two are the same?
When those two are the same, 1.
1. Plus log base 2 of 3. So let's do one more here. Let's say it was log base 2 of, I don't know, 4 times 7. So this becomes log base 2 of 4 plus log base 2 of 7. 4 is really 2 squared. So you can write log base 2 of 2 squared plus log base 2 of 7. You could bring this 2 out in front. 2 log base 2 of 2.
It could just be 2 plus log base
Exactly.
2, 7.
Yes, and that's the compressed form of this. All right, Jack, this is a pretty good place to stop. Thank you again for scheduling. I'll send these notes over and the recording pretty soon. So I hope you have a good holiday if I don't see you until after.
Thank you. I appreciate it.
You're welcome. Bye now.
Bye-bye.